In this video, we'll learn how to find the formula for the inverse of a function. Let's work through some examples to see how to do it. In example A here, we have the function f of x equals 1/2 x plus 3, and we want to find its inverse. Our first step in finding the inverse is to write y equals whatever the formula for the output of your function is. For our example here, we would write y equals 1/2 x plus 3. Our next step is to take that equation and swap the x's and y's. If you remember from our previous videos, if we look at the points that are on the graph of our original function and the points that are on the graph of the inverse function, the x and the y coordinates are swapped. So by swapping the x's and y's in our equation, we're essentially getting an equation for the inverse function. In our example here, if we swap the x's and y's, our equation is now x equals 1/2 y plus 3. Our last step here is to solve for y, and that's going to give us the formula to find the output of the inverse function. So in our equation, if we want to solve for y, we might start by subtracting 3 from both sides. This is going to give us x minus 3 equals 1/2 y. Then we'll solve for y by multiplying 2 to both sides. This is going to give us 2x minus 6 is equal to y. And so this tells us that the formula for our inverse function, f inverse of x, is 2x minus 6. So that's how we find the formula for the inverse of a function. We can always check if we have the correct inverse function by verifying that f inverse composed with f of x is equal to x. Remember that this statement here is just saying that when we input x first into the f function and taking the result and plugging it into the inverse function, that the two functions undo each other's operations and give you back the original thing you started with. So let's check that for this example. So if we do f inverse composed with f of x, this, remember, is f inverse of f of x. Since f of x is 1/2 x plus 3, our expression here is f inverse of 1/2 x plus 3. Now to evaluate this expression, we want to go to our inverse function, and where we have x, we're going to replace it with our new input. So that's going to give us 2 times 1/2 x plus 3 minus 6. Now to simplify this expression, I can start by distributing the 2 out here. Multiply it to the 1/2 x, multiply it to the 3. That's going to give us x plus 6, and then we still have a minus 6. And we see here that the plus 6 and the minus 6 will cancel out, leaving us with just x. And that's what we wanted to show. We wanted to show that f inverse composed with f of x is equal to x. So we see that our process here does give us the correct inverse function. Let's move on to example B. Here we have the function g of x equals 5x minus 1 cubed plus 2. We'll be following the same steps as before. Our first step is to write y equals the formula for the output of my function. In this example, we'll have y equals 5x minus 1 cubed plus 2. Next, we'll swap the x's and y's in our equation. So that's going to give us x equals 5y minus 1 cubed plus 2. Again, we do this because when we compare a function and its inverse, its inputs and outputs are swapped. So by swapping the x's and y's, our equation here now describes the inverse of g. Our last step here is to solve for y. That way we can describe the outputs of g inverse. So if we want to get y by itself, we need to undo some of the operations that are being done on it. We'll start by undoing this plus 2 at the end. We can do that by subtracting 2 from both sides of this equation, giving us x minus 2 equals 5y minus 1 cubed. Next, we'll want to undo the cube here, and we can do that by taking the cube root of both sides. So do the cube root of both the left and the right hand side. This gives us the cube root of x minus 2 on the left-hand side, and on the right-hand side we'll be left with 5y minus 1. Next, let's get rid of the minus 1 at the end here. We can do that by adding 1 to both sides of this equation. So we'll have cube root of x minus 2 plus 1 is equal to 5y. And then we just have one last step. We need to get rid of the 5 multiplied to the y. And we can do that by multiplying both sides by 1/5. So we end up with y equals 1/5 times cube root of x minus 2 plus 1. And what we have here is the inverse of g. We have g inverse of x is equal to 1/5 times cube root of x minus 2 plus 1. Let's work through one last example. In example C, we have the function h of x is equal to x minus 2 divided by 3x plus 5. Once again, we'll start by writing down the equation y equals the formula for the output of my function. That's y equals x minus 2 divided by 3x plus 5. Next, we swap the x's and y's in our equation. We have x equals y minus 2 divided by 3y plus 5. Our last step here is to solve for y. Now, when we have an equation involving fractions, typically what I like to do is get rid of the fractions by multiplying both sides by the denominator. So let's multiply the right-hand side by 3y plus 5, and also the left-hand side by 3y plus 5. Now, on the left-hand side here, if we take the x and we distribute it inside the parentheses, that's going to give us 3xy for the first term, and then plus 5x for the second term. And on the right-hand side here, the 3y plus 5 is going to cancel out with the 3y plus 5 in the denominator, leaving us with just the numerator y minus 2. Now, if we want to solve for y, we want to get everything that has a y in it on one side of the equation, and things that don't have y's in it on the other side of the equation. In order to move this y to the left-hand side of the equation, we'll subtract y from both sides. And to move this 5x to the right-hand side of this equation, we'll subtract 5x from both sides. So we're going to end up with 3xy minus y equals negative 5x minus 2. Since all of the terms on the left-hand side have y's in them, we can factor those y's out. So on the left-hand side, factoring out the y, that leaves me with 3x minus 1. And on the right-hand side, we still have negative 5x minus 2. Now there's just one last step to get y by itself, and it's to divide both sides by 3x minus 1. So dividing both sides by 3x minus 1, we'll just be left with y by itself on the left, and then on the right we have negative 5x minus 2 over 3x minus 1. And that's our inverse function. We have h inverse of x equals negative 5x minus 2 divided by 3x minus 1. So in this video, we learned how to use the formula of a function to find the formula for its inverse function.